Okay, good morning everyone. In this video, we're going to review a little bit on our lecture 3 data structure, and we will coding together in the implementation. So from the previous video, as we can see that there are two types of implementation. We either can implement as array or dynamically create nodes. We use pointer. So in this video, we're going to implement using this one. I think this one normally we don't use it because it only works for the perfect binary tree. You can also try it yourself using this rule. And from the previous video, as we can see that we see the characteristic of the tree, also the function that we can access to our data, whether we use the pre-order or in order or post order. Okay, so we are trying to implement that. As we can see from last time, we have a function to insert our node, and based on the rule in binary search tree, the bigger data it should be inserted into the right, less data should be inserted to the left, right? So we recursive left or recursive right, okay, based on our condition. And at some point when we reach the leaf, it means that we not be able to go further, right? We just create our node dynamically created right there. Okay, and we also see that how we access to our data using different form of traversal. Pre-order in the depth first search, we use this rule, data left and right. We display data and then we recursive left and then right. And in the in order, okay, left, right, left, data and right. Okay, left, data and right. So we display is in the middle. We recursive left, we display, and then we go right. Also in the post order, it means that we recursive to left, right, and then we display it, because post it means that we display it lastly. We will implement that, and you can also verify with this after we implement in the program by using pre-order, in order, and post order. You can check it manually, as we seen in the previous video, how we can visit our data, whether we go left and right, and then we display one by one. And we have seen and how we can search our data, just recursive left and right, we comparison. If you can find it, you return true, otherwise you return false. Okay, and we've seen that how we implement it using this data structure. First, we create a node. Next, we create a function to insert our data, and we also create another function to search if we want to. And to access and display our data, we use the depth first search here. For example, pre-order, using the rule here. And finally, we can test the main program here. Like we create a root, which is null first, and then we try to insert one by one, and we display it. Okay, this we are gonna go through this from step 1 to step 5. Also, we can also find the sign of the tree by recursive left and right, and try to count one by one. Okay, so now we go to the code block. We will create all of the function. Let me create a new file here. Let's say this is a tree as linked list. Okay, that's cpp. So this one, let's say, okay. So firstly, we create the structure of the program. Okay, we are using namespace std, and we have the main program, right? So first thing first, based on our step here, as you can see, you create a data structure. Okay, let's say you create a struct. So I put it element or node is fine based on you. Let's say I put it node, or you can put it element is fine. And then inside this node, what do you want, right? What do you want to store? Normally you have the data that you want to store. Let's say I want to store integer number, let's say data here, or you can have some more data like string name, other information you can put in here. Or you can also create a struct student up, and then you create a variable student here. It's fine. Okay, so that just to make it simple, we just put an integer here. You can create more variable actually. And what we need next is the left child and right child, right? Because node here normally it can point to left and point to right in our binary search implementation. Okay, we put it left, And then we have right, okay, left 3 and right 3, which is the pointer. And that's it for the nodes. And next we can create another function, right, to insert our data. So we put node here. It is a pointer because we dynamically create our program. Let's say insert data. Okay, because insert here is like a result keyword that we can turn it into green. So insert data into our tree, and we need to pass a root and the new data. Okay, new data that we want to insert into. So in here, what we are going to do is like based on the rule of BST, we're going to check condition something, right? So let's say I check first our new data is greater than the root data here. So this is how we access to pointer data, right? And then we check if it's greater. It means that we go to the if we see that our new data here is greater than the root, it means that we must recurse it to right? So I put right root it has left and right, so I put right gat, and then we pass it into the function insert our data here. We need to provide these two parameter, right? Because we recurse it to right, we must provide right. Okay, root right. And then the same is our new data. Okay, this one recursive, and then we have another recursive if our new data is less than the root data. It means that the number that we should want to insert into, it should be on the left. Okay, because this data is less than the root data based on rule of BST. So root left, because we can recurse to left. Root left equal to insert our data, insert root left. And then we pass the data that we want to insert into. Okay, so now we go left and right, and in case finally if our root here it reach the nil, okay, this is the rule that we're going to insert, right? Because with the go left or whether we go right, if the root that we pass here is actually a nil, okay, then we can insert, right? So in this case we cannot test this condition first, because sometimes if the root is nil, we cannot access to root data, right? There will be something error. So normally this one should place on first. We check first if there is no data. If root has no data, okay, it is nil, right? Because sometimes when we create the tree, when we have no other data, right, the tree is empty. It means that we must create our data there. We cannot access to root left and right something, right? So in here we can just say how we gonna create it, and we can also make the connection together, if, else if, so on and so forth. And we return the value as well. So I'm gonna make new data in here. Let's say roots new nodes. We got a node, and then this root, it has the data should be the same to the data that we want to insert into, and we have the pointer, right, which is left equal to nil, root right equal to nil, because we insert our data there, and then that node has no left or right child. Okay, so now you can make this together. Let's say if here to make connection. Okay, and finally we return the root variable. Okay, so this will dynamically create the data tree for us. It will recursive one place by one place, and then when it reach the place based on the rule that should be inserted into, and based on it, if this has no other child, then okay, it create it there. Okay, next, I think that's it for the insert. We can create a search function, or we can display. Okay, let's say display. Why I put pre-order? Okay, pre-order method. We must need to provide a root because we display, right? So we can use the condition. If root not equal to nil, but we will recursive inside here. Okay, otherwise this function is stopped. So in here, because we use pre-order, okay, we display first data left right. So see out, our data is inside the root here. Okay, we're gonna put a space. Okay, and then we must recursive. Okay, recursive we call to the left and right. So we're gonna call this function again, recursive, and we pass our root here. We go left. Okay, we pass left node of the tree, and next we also need to pass root right of the tree. Based on the rule pre-order, we must use data left and right, DLF, DLR, sorry. Okay, I think that's it for the function that we need. We can now test our tree data structure in main program. So I'm gonna create a node here. Let's say L1 is all the roots equal to nil first. If we don't assign it to nil, this function may not gonna work, because we're gonna stack some condition and then we're gonna create a new data, right? In case that our tree is empty, we must create first. It does not have any recursive, so the condition must be met. So we must first provide L1 equal to nil here. You can put any name, it's fine. It's just the variable name of our tree. So next we're gonna insert L1, insert data. Okay, we must provide a root here. It's because this function return each node, right? So we must take air here equal to the function. We pass L1 and then the data that we want to insert into. Let's say I want to insert number 10. And next I want to insert some other number. Let's say 15. It go to the right, and then this one 7, and it go to the left. Okay. So let's say we're gonna display it pre-order. Gonna pass L1 here. Okay, I think that's it. We are ready to go. So just for your information, that we remark that every time we insert, it follow one by one here. So 10 first. At first it nil, right? It has no data. So 10 become root of the tree, and then it insert 15 based on the rule of BST. 15 is more than 10, so it insert into the right. So if we construct this tree, it's something like we have something like this, right? Okay, first it has this number inside, which is number of 10. Put number 10, and then 15 should be coming here, right? Okay. When we create it first, this has no, at first no, right? Nil, and then when insert 15 now here. And next we insert number 7. Okay, number 7 less than 10, it should be created in here. Okay? Number 7. Okay, so this is how we're gonna construct the tree. And okay, let's run this program and check if there's something wrong. We can check the error message. Okay, we cannot run. Let's see the inspection on the error log. Build message. Cout was not declared in scope bar. Cout number 27 something, but cout. Okay, it's using namespace. Okay, because we include something wrong, right? In C++ we cannot include .h here. Actually, this is for printf and scanf. So I'm gonna change it to IO stream. Okay, now we can run it. There's something wrong, it's still loading. Okay, we cannot display, right? Okay, let's see and check the code if there's something wrong somewhere. We can debug the code. Okay, create a node here. Our data we have left and right, and we insert our data into if the root is okay, like this one is not equal to nil, right? We will insert when it will reach nil, right? This is the wrong condition, because for example in here, as you can see, when we create something like this one, okay, at first when we have number, let's say 10, the left and the right is nil, right? Okay, so it means when we create, we want to insert some more number, let's say number 15, right? 15. So 15 should be inserted to where? It should be inserted to here, right? To here, right? It should not now nil anymore. Okay, so it means that our condition try to reach when it equal to nil. Okay, we will create new element right there, right? So this how why we condition we put it equal to. Okay, let's run it one more time. Okay, that's it. So based on the rule that we use pre-order. Okay, pre-order here, based on the pre-order rules, we take number let's say this one we have 7 also. So pre-order we get data first, left and right. Okay, left 7 and right 15. Okay, so this 10, 7 and 15. Okay, I think that's correct. You can test the program out. I think we have sometime in the code in the slide right here, like right here. So when you want to insert right here, okay, in order to construct this tree, okay, you need to insert it level by level. Insert 50 first, then you insert 17 or 17 or 72 is fine. Level by level, okay, level, first level, second, third, and fourth. So I'm gonna construct a tree something like this. I'm gonna see whether our pre-order work, and we will create some more function in here. Just create some function, just change something, right? So I'm gonna insert this data here. Let's say first we insert some number. Let's say I'm gonna comment this out. Control Shift letter C to command it. So 1 equal to insert our data. We pass numbers 50, right? Okay, yeah, 50. And then we have 17. We have 72, okay. And then we have the third level, 12, 23, 12, 23. And we have 44, 54, and 76. 54 and 76, and in the last level we have 9, 14, 14, and we have 19 and 67. Okay, 19 and 67. Okay, this we're gonna construct a tree like this based on the rule level by level. We insert our data, and now we call to the function pre-order. Okay. So what we expect in here, you can try it manually. What is the output for this tree? We're gonna get like 50, 17, so on and so forth until 76 in the last. Okay? So I'm gonna insert it. Okay, so this is pre-order. Okay, there's no sorted right unless we use the in order traversal. So this is the rule that we get from our program. You can also check it manually. So next we're gonna create in order and post order function. So just put it in here. Let's say y in order. Okay, in order function. So in order, what is the rule, right? We in order, it means that we go left data and right, because in the tree, if we focus on the tree here, we have left data and right. So in order, it's like left first, data and right. So in the function, it's the same to before. We check if it's equal to nil. We're gonna display our data and loop, because in here if we put equal to nil, we cannot access data, right? So the condition must be not equal to nil, so that we can access to data. So because we use in order, right? So we put we call to the function first, in order, in order, and then we pass note here, root. And then data, okay, based on this rule, after go left, okay, root left here, we pass root left, and then we access to data, which is we can use the out root data here. I'm gonna put a space. It's fine if you put an enter, and we have to recursive right. This is right subtree. We must provide a right parameter, root right. Okay, that's it for the function in order. Let's say we're gonna make post order method, nodes root, and based on the post order, the rule is that we go left, we go right, and then our data is put at the finally. Okay, because we use post, right? Post, it means do something first, and then our data is displayed lastly. So we're gonna make our recursive root not equal to nil, and then left. Okay, we're gonna call to this function either to recursive left, post order. Okay, root left, and next we're gonna recursive to the right, root right, pass the right parameter, which is the subtree, and finally, which is the data, right? Just display it. See how our root here, they have data, they have space. Okay, that's it. Okay, now we can call to the function in here. Okay, in order to display our data. So I'm gonna create a, let's say we new line, otherwise we will get our data in the same line. Okay, reorder in order method, and we have the post order. Okay. So the first line should be the data from pre-order function, the second line should be in order function, and the third line should be from our post order function. Okay, something wrong maybe somewhere. Let's see the error. We cannot run it. Display message. Okay, data was not as clear in the scope. Okay, let's see 36, the line 36 here, 36 root data. Okay, because this one we put something wrong, like it should be a symbol like in which we access to our data, because root is a pointer, we use this symbol. Okay, little mistake, error. Okay, this is what we get from our program, and you can actually compare to manually when you test on this one. So as you can see in here, like this is the in order, right? In order, we call it in line 70, and the number that we get is in sorted order, because BST based on the rule apply, go left and go right, and finally we get the sorted order. And for some cases that you have the number is the same, okay, because sometimes the tree it store the duplicate. The rule is actually we try to optimize our data, not the same data. Mostly they must have different data, no duplicate at all. However, if you want to design the program to be able to store the duplicate data, it's fine based on your concept. So in this case, you need to decide whether you store the duplicate number on the left or on the right. It's fine. So let's say in here you want to insert a number, and then in case it equal more than or equal to, you put it on the right. It's fine. Okay, so let's say I put here 76 again, and then you need to provide the rule in which you insert your data. Okay, so greater in, and then you put something like greater than or equal, right? So in this case, in case there are duplicate data, you want to insert into the right. It's fine. You can still do that. So this is what you want, as you see here, like this is the duplicate, right? Duplicate, but it's fine. Okay, the data work normally, but just like I mentioned, normally we try to store the unduplicate data. Okay, I think I hope you get it, and you can actually try to implement the search function. I will not gonna make it. You can try it yourself when you want a search function, and then you can recursive left or right, and then if it get what you want to find, it equal to, yeah, you return true, because you search boolean. And you can also try the get function, the size of the tree here, okay, using this method. Okay, I think that's it. Thank you for your attention.